Can you hear me now? Okay, good. I think we should get our 1 minute back because we have lots of material to share. So hopefully, we can go 1 minute past. So welcome to the session again. So in this session, we're going to talk about Amazon SageMaker Ground Truth. As you know, yesterday, as part of Andy's keynote, we launched this service. Amazon SageMaker Ground Truth makes it easy for you to build machine learning application by making data labeling easy, cost efficient, as well as highly accurate for you. So let's go into the details of SageMaker Ground Truth. Now, before I do that, let me introduce myself. I'm Rahul Sharma. I head this project initiative. With me, I have Professor Pietro Perona. He is a lead scientist on the project. And we have Chad Valquist, who is from Tyson Foods. He is one of our customers. So when you build machine learning applications, the core part of that is to train a machine learning model. And then you use that machine learning model to do predictions against the data that you haven't seen before. Now, as part of training the models, you take inputs as labeled data sets. And it's very clear that quality machine learning models are very much dependent on how good your training data sets are. Right? Now, as you train the model, the machine learning model basically learns from the various patterns that it sees as part of the labeled data sets. And then once it understands all these patterns, then you can use that machine learning model to do predictions against the data that you haven't seen yet. Now, in terms of the quality of the training data sets, so that's a key aspect here. Right? Now, let me give you a very simple example. If we are building a machine learning model to distinguish between cats and dogs, in order to build a good model here, you need lots of images of cats and dogs that you would use to train your machine learning model. And once you have done that, then you can use that machine learning model to do quality predictions to distinguish between cats and dogs. Now, that's a very simple example. But if you look at much more real-world applications like autonomous driving, facial detection, transcribing, these are much more complex applications. And in this case, the need for a quality training data set with quality labels becomes even more paramount. So now, data labeling is indeed hard. Right? If you look at existing solutions out there for data labeling, they require a lot of human effort in order to get the data labeled before you can use that for training the machine learning models. Okay? To give you another example, if I'm building a machine learning application to do autonomous driving for the cars, I need to take thousands of hours of videos. And I need to label these frame by frame. Now, in order to do the labeling for such immense amount of data sets, you have to require human labelers to be actually involved as part of taking frame by frame, going and labeling interesting objects as part of your that particular data set. And the goal here is, as you go label these interesting objects, such as pedestrians and other cars, as well as the traffic signals, you do it accurately, so the machine learning model that you're actually developing is able to do accurate predictions on top of that. Okay? Now, this requires, if you have to take these thousands of hours of videos in this autonomous driving example, this requires, in certain cases, thousands of human workers to actually go label the data set. So it's a very expensive, costly, and time-consuming effort that you have to do for machine learning and data labeling as part of that. Now, going further, if human workers, when they label the data set, they actually make mistakes or they do some incorrect labeling, some of those inaccuracies actually go into your machine learning model. Right? And any inaccurate data would cause inaccurate predictions, and some of these have real-world consequences, say in the case of autonomous driving example that I talked about. Right? So overall, the accuracy of machine learning models is a key aspect, and good data labeling is very important to make that happen. Now, last year we launched Amazon SageMaker. So this is a managed service that makes it very easy for you to build, train, and deploy machine learning models as part of developing machine learning applications. So this service, since launch, almost like 10,000 customers plus have been using this particular service. So using SageMaker, you can take a notebook. You can use that notebook to prepare your data. Next, you can use the first-party algorithms that we have as part of SageMaker. Then you can use these first-party algorithms to train machine learning models. And then furthermore, you can take these machine learning models and do a one-click deploy to actually do predictions and inference against those particular models. So a very simple managed service to do build, train, and deploy for your machine learning applications. Now, a lot of customers have been using it. So as we talk to these customers, one need became very apparent. Right? As I said earlier, like in order to do good machine learning models, highly accurate machine learning models, you need quality label data. Right? And given the existing solutions can't meet their needs, so the need was very apparent when we talked to the customers. And this is the very reason that we worked on and launched Amazon SageMaker Ground Truth. Now, as part of SageMaker, so SageMaker already supported build, train, and deploy as part of its workflow. Ground Truth adds data preparation and labeling on top of that, giving you a very well-integrated label, build, train, deploy flow as part of SageMaker. Now, the fundamental value propositions behind Ground Truth are, so first of all, it makes data labeling very easy for you, and we'll talk about how it does so. The second, it reduces the cost for you, so it's very cost efficient. The third thing is in terms of accuracy. Right? Especially accuracy is, again, the key behind quality machine learning models. So these three value propositions go behind making SageMaker Ground Truth the solution that we created around data labeling. Now, let's start with the three value propositions. So I'm going to talk about first ease of use, then cost efficiency and accuracy. So in terms of ease of use, as part of SageMaker Ground Truth, we support built-in workflows or labeling tasks. Now, these labeling tasks include pre-configured UX as well as the flows. So as part of creating a labeling job, you can use one of the workflows that you see there and quickly, just through point and click, configure a labeling job and get going. So as a part of the launch, we have 4 predefined workflows that we are supporting. These are bounding boxes, image classification, semantic segmentation, and text classification. Now, if you have some more advanced use cases or you need a lot of customization as part of creating these labeling jobs and labeling tasks, you can use custom tasks, which allow you to do the customization of the flows as well as the UX. You can hook in Lambda functions as part of the labeling task to do some pre-processing and post-processing for your labeling job, and then use that to do custom tasks for your labeling applications. Now, in terms of reducing cost and increasing the accuracy, Ground Truth uses a combination of active learning and auto data labeling. Active learning is a machine learning technique that basically uses a set of algorithms to decide from your input data sets what a subset of data can be labeled by humans versus what can be labeled automatically by machine learning models. And part of this is the auto labeling that is done using the machine learning models. Now, the way Ground Truth does active learning and auto data labeling, it starts with the input data set that you provide. So going back to my example of cats versus dogs, so you provided an input data set. Active learning uses an algorithm to pick up a random subset of images from your data set. It sends those images to the human workers. And these human workers actually label those particular images. These labeled images are then used by ground truth to train a machine learning model. Now, the machine learning model that is trained depends on the task that you are performing or the use case you picked up as part of your labeling job. For example, if you're doing bounding boxes, then we use the first-party algorithm that is as part of SageMaker, which is SSD object detection algorithm, to train a machine learning model. Now, as you get these labels back from the humans, a machine learning model is being trained. And then ground truth uses this machine learning model to automatically label a subset of your data set. So incrementally, more and more percentage of your objects or images would be labeled by an auto data labeling using the machine learning model that is being incrementally trained. So next, then ground truth again picks up another subset from your input data set, again sends it to humans for labeling. The responses that come back in terms of the labels are then used as part of further training the machine learning model. So this incremental training as well as labeling continues until the desired accuracy level is achieved or a stopping condition is reached. For example, the stopping condition could be like the whole of the data set has been labeled now. Okay. So this combination of active learning and auto data labeling, the overall objective here is to reduce the amount of human labeling that has to be performed, and the goal is to try to auto label as much of your data set that can be done. Right? So by reducing the overall human labeling, the overall cost of the labeling job that you initiated with ground truth goes down, so giving you more cost efficiency, as well as the higher accuracy is achieved because a machine learning model typically would do better accuracy labeling than, say, corresponding to humans. Right? So this is how ground truth achieves a combination of cost efficiency as well as accuracy for your data labeling jobs. Okay. Now, when you configure a labeling job, you get options of different workforces that you can use as part of configuring the labeling job. So presently, we support 3 particular options. So you can use public, private, or vendor workforces. A public workforce is through Amazon Mechanical Turk. So this is like 500,000 crowdsourced workers that you can use to get your labeling jobs completed. Now, if you are very sensitive about not sending your dataset objects to public workers, you can configure a private workforce using ground truth. This private workforce uses a Cognito user pool underneath, and it supports full authentication authorization for objects as they are given to the private workers to work upon. Now, the third option is vendors. So vendors is a curated set of workforce options that we have provided as part of AWS Marketplace. These vendors you can use specifically to get work done if you have very specialized labeling jobs and you need a third-party vendor workforce to work upon that. So I'm going to now switch to giving you a demo. I talked about a lot of concepts here, but you would see actually at work as part of the demo that I do. So here you see the ground truth as part of the SageMaker console in AWS Management Console. So I have a set of jobs that I already ran. So now to go through the demo quickly, like I'm going to take an existing job, and I'm going to clone it, and then I'm going to walk you through the different configuration that you can do as part of a labeling job. Okay. So as I mentioned earlier, when you create a labeling job, you start with an input data set. This is where your images or text documents would be. Right? Now, the way you provide an input data set to ground truth is through your S3 bucket. Right? So this is your own S3 bucket. You put all the images there, and either you can create an input manifest, which is like a JSON format that you can use to provide inputs into your labeling job. Or if you have a bucket with large number of images or text documents, you can use the crawling option here. So in this case, what I'm trying to do is create a labeling job to create an object detection model for identifying dogs. Right? So the task that I would configure is bounding box. So you see the input manifest that I provided as part of this is dogs.manifest. And these are all the images that I have in my S3 bucket. Then as part of the labeling job, the output, once the labeling is completed, it goes into an S3 bucket, again, that you provide. And this is an output manifest, which has a list of all the labels with labels per object. And you can use this output manifest as an input into training a particular model. Now, in order for your S3 bucket to be provided access to ground truth, you have to configure IAM roles for that, giving the permission. Now, as I mentioned earlier, we have 4 pre-built labeling task types that we support. So these are image classification, bounding box, text classification, and semantic segmentation. I'm going to choose bounding box in this particular case. You can also choose custom tasks if you want to do certain customization with custom templates, as well as specific flows with pre and post lambdas that you can hook into a labeling job. There are 3 choices of workforces here, public, private, and vendor. In this demo, I'm going to use a private workforce. I already have a workforce created using a Cognito user pool underneath. You'll see how that works once I go to the next step. Then I need to provide instructions for the workers to perform this particular job. Now, as you may imagine, like clear instructions are very important here. Because if you provide incorrect instructions, then labeling could be incorrect, and that actually contributes back into an inaccurate machine learning model. Okay. So here, I'm trying to be a bit terse just for the demo, but normally the expectation would be you give good examples, bad examples of what these labels would look like. Okay. So my instructions are simple. Draw tight-fitting bounding boxes around each dog you see in the image. Now you can preview your data set. Because you may have large number of images in your data set, and you want to see how it would look as it goes to the workers. So I'm going to just quickly see that. I would do a preview. Obviously, the pop-up is blocked. So this is what the workers would see when they do the data labeling. And we'll see an example of how a worker would perform a labeling task. Okay. So I'm going to submit this job. Now I switch personas. Now I'm the worker, a private worker who is going to do the labeling for the job that I just created. Okay. So I'm going to start working on this particular job with a set of tasks that came to me as a private worker. I get clear instructions. Again, I said draw tight-fitting bounding boxes around each dog you see in the image. It tells different classes of labels that could be done for this particular labeling job. I only had one class, which is dogs. I'm going to draw a bounding box. I submit it. I have around 20 images, like exactly 20 images here, so I don't want to do all the 20 right now, but you get the idea. I want to make it just a bit tight-fitting here. Okay. So now, as a private worker, I'll go through all these images, complete the job. Now, this could also go to, depending on how you configured your labeling job, could go to public workers as well as vendors as well. So now going back to a job I ran earlier, I want to show you the output of what the labeling job got from the private workers. So I had 20 images. You see the bounding boxes around each of the dogs in each of the images. So I think it's showing up okay. Yeah. So I have all the 20 images here. Right? And also you get the output manifest, which would have all these images with the corresponding labels, which you can use as an input into training your models. Right? Now, one important aspect I want to mention is that when I created the labeling job, I didn't turn active learning and auto labeling on. A typical recommendation is that if you have more than 1,000 objects, then you should turn on auto labeling to get the benefit of cost efficiency and accuracy. Now, when you turn auto labeling, one of the big advantages of ground truth is that you would always also get a model as an output from SageMaker. We do the training using your own account in SageMaker, and an output of that is a model that is trained that you can just deploy by one click to do inference on top of for your particular applications. So with that, I'm going to invite Pietro Perona to go into more details of the science behind ground truth. Let me switch it back. Yeah.
Thank you, Rahul. Okay, so I'm in charge of science with a bunch of very talented people at Amazon. I want to tell you a few of the thoughts that go behind ground truth. As a professor, I've been working for about 10 years on this question. There are lots of papers written, and today we'll just give you a sense for a line of thinking. What I would like to spend a moment telling you about is, first of all, this question of label consolidation, so how we take the input from many annotators and consolidate it down. So does anyone here know what kind of a puppy is this? What breed of a puppy? Shout it out. Shar-Pei, okay. So let's see what our annotators are saying. So we have 4 annotators here, and first one is Mario. It says Bulldog. Then there is Anne, who says Shar-Pei. Bob, Bulldog. Doug, Bulldog. Okay, so classically, when you want to aggregate the opinion of many people, you do majority voting. We do it for electing a president in this country. And what comes out? And so the answer is clearly Bulldog. But there are many questions here that you may come up with. One is, well, we have an even number of people. What if they come out even and even? And would there be a better way to think about what they say? And clearly, if we can estimate how likely are they to say the correct breed when they label our images, then we should be able to do better than just doing majority vote. So in this case, we have behind-the-scenes logic that allows us to correlate lots of things that these annotators do, and we can estimate how good they are, and these are probabilities that they will say the correct breed. And so we see that and second annotator is a dog expert. Everybody else is somebody who is fairly interested but not particularly good. Once you know the probabilities, you can consolidate the opinions of these people. There is some fairly simple math. It's Bayesian statistics. Some of you have gone through it in school. And now you can give the proper weight to each annotator. And so the final equation is here. What's the probability that a Shar-Pei versus a Bulldog? Conditions on what each person has said. And it turns out that it's 10 times more likely that Shar-Pei is the right breed because Anne is right most of the time. And so I don't have the time to tell you all the details about this, but now we have 2 very valuable insights. One is we can get better quality answers out of whatever annotators we have. And the second one is we don't need to commit to one answer only. We can give you a final probability that allows you to decide if you're satisfied. You may have a margin of error that has to do with your business that tells you I need 99% or I'm happy with 70%. And so we can give you something to work with at the end of the day. And we give you some tools within ground truth to choose how accurate it should be. OK, so that was the first point, namely, there is a very good, solid probabilistic structure behind how we take into account the input from annotators. And we give you out an accurate result. And we also give you the means of deciding whether the accuracy is good enough for you. Second point is, how do we give you better value by employing active learning to only ask the real people to give us opinions on images where their opinion is needed, but not waste their time. So here is the idea. Once we have label consolidation, we go from input data sets to label data sets by combining the input from many annotators that we've seen. And now, once we start having a bunch of labeled data, maybe 1,000, 2,000 labeled data, we can start training a computer vision system that can take the input from the annotators, the input from the input data set that you have, and produce labels instead of sending it to the annotators. So do we trust the machine to do it a good job? Do we not trust it? And so here is the bit of extra oomph that needs to come in. The computer vision system that we train, and it's not easy, has to have an internal value of confidence that what it's doing is correct. And so the idea is that there is some logic here which, when the system is confident, will feed the labels into the final pool of labels that it will be using at the end. But if the confidence value is not good enough and the system hasn't learned to deal with a certain image, the image goes to the annotators and comes back. The labels come back to the learning to improve the computer vision system. So this loop, the red loop, is called active learning. And so the idea is to select the difficult examples, the ones that push the envelope of the computer vision system, and have the humans as the ultimate arbiters of whether those images, so what label to assign to those images. And so the more data you have, the more the computer vision system learns, the better it will be at annotating, and the more frugal, the more cost-effective your labeling job is going to be. So quickly, I wanted to show you a couple of experiments. Here is a data set. Here is a data set called NA Birds that was produced by my students at Cornell and the Cornell lab, at Caltech, and the Cornell Lab of Ornithology. It's about 300,000 images of birds that are annotated with a species, the bounding box, a lot of things. And so it's a good data set to work on. And we trust it a lot because true ornithologists went through it. It's very expensive to do it, but we did it once. And so this we can send out to a workforce and see what happens. And so we give the workforce target images to tell them what we mean by owl, what we mean by woodpecker, hawk, and so on. And so this would be the reference images we send out. And here is the output of the experiment in synthetic form. These are things we look for. So on the x-axis, you have the number of images that were annotated by hand. On the y-axis, you have the number of data that were processed by different mechanisms. So the yellow line that is a perfect diagonal is how many images were annotated by hand. Well, the y-axis must be the same as the x-axis. But what you see here is the green line, that's an important one. And you see that as the number of images labeled by humans goes up, then we have a bunch of images that start being labeled also by the machine. So the machine is getting more and more confident in taking over the images. So in this case, it was deciding which one is the species of the bird divided up into 10 different categories. And we have about 8,000 images labeled by humans and maybe another 4,000 labeled by the machine. And the further the machine goes, the further the experiment goes, the better the machine becomes. So the next thing we want to look at is what is the accuracy overall. And we have a target for this experiment of 0.9. And what you can see is that the green line, which is the machine, is hovering around 0.9 accuracy, meaning 9 correct, 1 wrong. The humans in the background are combined with the machine are getting better and better. So the humans are getting better because they get a hang of it, so they themselves improve. The result is that the total accuracy is getting much better than 0.9, which is what we were shooting for. So here is a typical example. So this is one of our early experiments in which we are still tuning the confidence parameter to allow the machine to be a little bit less accurate, to be more frugal if that need be. Here is the cost. So in this experiment, the humans were being paid 5 cents per image. And due to the fact that there is quite a bit of images being labeled by the machine, the cost is coming down, and it's now hovering around 3.5 cents per image. So there is some saving. Second experiment, detection. This is similar to what Rahul was telling us before about dogs. This is about putting a bounding box around birds. And what you'll see here is the ground truth. So is the annotation provided by our system. It's the orange box. And the annotation was provided by the NA Bird annotators, and it's a blue box. And what we are happy about is that the boxes are very similar, very equivalent. So there is a measure for the agreement between two boxes. It's called intersection over union, IOU. And so when you will get into this and you will start working with this kind of tools, you will read our blogs and technical reports, and you will learn about all ways in which we measure performance. And here you have a few examples. And here the numbers are better than before. So it turns out that for bounding boxes around birds, the machine learns incredibly fast. It's an easier task than in the species. And so what happens is the machine ends up annotating a whole lot of images right away. And so what you see is that the machine, so the humans get to annotate up to 2,000 images, and the machine is already annotating 10,000. And the cost drops like a rock. So if you only use the human annotators, you would pay, in this case, 15 cents per image. So it depends on how many people you're employing. And so here there were 5 annotators, so 3 cents per annotator times 5, 15 cents. But the cost of a machine is almost 0, and so the final cost of this annotation was less than 3 cents per image. So it's like a fraction of a fifth of what would have taken with just humans. Okay, so I wish there was more time and I could show you also about semantic segmentation, which is a process of filling in the pixels that correspond to the figure of an object, but I won't, and so you will play around, and you're welcome to ask questions later. And now I would like to pass the hand on to Tyson, who is our most courageous customer, and here you go.
Thank you, Pietro. This is on. You guys hear me? All right, cool. I'm Chad Walquist. I lead the emerging tech team at Tyson Foods, and just give you a little background on Tyson Foods. Everyone thinks Tyson, they think chicken. Well, we actually do beef, pork, prepared foods. We're also investing in alternative proteins. You can see here the numbers are staggering on the volume of food and the amount of people that we feed on a weekly basis. And so our goal is, how do we become the world's premier protein provider? And so part of that, we undertook a digital transformation about a year and a half ago, and a lot of that has innovation work with Amazon. So just kind of jump into, what are we doing? What are we trying to go after? So one of the key things for us is, how do we start to try out new things? How do we test them? So that's why my team was created last February, is let's go out there, let's take risks, let's move fast, let's try things. And so one of the things, we took the team out to Seattle, looked at the Amazon Go store, we started making a connection. I wonder if we could put cameras in the ceiling in some of our production facilities and actually start to track our production, where it goes, and identifying it automatically. So think about inventory. What did I produce? Where is it going? And where did it end up, so I can find it again? And so I'm going to talk about the first one. Is if you can't know what it is, knowing where it is, and it doesn't really do any good. So what we're focusing on right now is, identifying the product first, and we've actually started to build algorithms to locate and track as it enters and leaves the room. So we've worked really closely with Amazon R&D. We worked with the ground truth team in SageMaker. And so part of this thing is, how do we optimize production? How do we accurately identify things at the pace? So you saw those numbers in the first slide. Things are moving quick. Lots and lots of volume. And so we got to make it seamless. How do we start to reduce the amount of change that we're introducing to things so that it can make it real easy? The other part of this is, how do we shift from investing in software and systems? How do we invest in our people? And so using AWS in the cloud and starting to invest in open source software like OpenCV and some of these things, can we create really simple systems that are elegant and work really well? So the thing I'm going to show you about today is, we've got products moving around the plant. Can I automatically identify them when they're going to scale so we can register that as inventory? So you can see these racks, we call them. We'll show you some real pictures of them in a minute. As those are moving through every few seconds, they go on a scale. We're like, there's a guy typing in a number. There's people doing hand signs of a wing, boneless, there's thighs, right? And it's not that we got here wrong. We got to the size we are honestly, and what got us here won't get us to where we need to go. So how do we change that? How do we get people on board? So we had an idea. Can we put a camera over the scale, and when the guy types in the number, can we correlate the image to what he's typing in to have him help train these things? And so the other piece of this is, you saw those numbers. Huge volumes. Traditionally, R&D, innovation, money follows your margins. Well, on our poultry business, some of our lower margins. So what we're trying to do is flip it. Can we use low-cost open source software, invest in our people, and can we do that in a way that changes this just by a fraction of a percentage because we have such huge volume? And so that's what we're trying to do. So computer vision, it's hard. The labeling, really hard. We thought, oh, the machine learning is going to be hard. We don't know all the different models, all the different techniques. We had a hard time just getting to that. Labeling these images turned out to be 80+% of our work. We spent months. We tried open source tools like Pybasa. We tried all sorts of stuff. We had teams of people, interns, whoever we could get to start labeling. It was tens of thousands of images labeled by hand. It was awful. I was one of the worst labelers. My team was joking. They're like, you just start clicking through it. And I was bad. It's harder. It's tedious. So how do we reduce that? Also, how do we get images from multiple different situations? We found overtraining is really simple to do unintentionally. You know, we put one camera up, the first model was good, we put a new camera up, it doesn't work anymore. Crap. So how do we get through more images for more situations to help us so that we're not overtraining things? So other thing we saw is the manual annotation slow. We have about 300 to 400 different SKUs at a typical poultry plant, for example, and in thousands at a beef plant, for example. So huge amount of images, huge volume. How do we do this in an efficient way? So other things you should know. We have remote plants. We've grown through acquisition, so we've got stuff in the middle of Tennessee. We've got stuff in rural areas, so a good internet connection for us is 10 meg. Now we're trying to make that more robust, but right now, connectivity is a hard thing. Our plants, you know, we're all about food safety, so our plants are washed down, sanitized all the time. They're cold to keep the product, you know, fresh. So you've got cold, wet conditions. That's not friendly with computer hardware. We've got a lot of challenges of how do we compute, how do we do these things at the edge. And then how do we deploy it at scale? You saw we've got about 120 facilities across, 120 different plants across our business. How do we manage computer vision? We had a hard time labeling for one camera in one situation. How are we going to scale that across 120 facilities among many cameras? So those were challenges that we've kind of saw as we started to go down this path. So we started working with the Amazon team. When we started to explain the problems, like, hey, we're working on something, maybe we can partner on this. And so when we started to see things about active learning, wow, that's really cool. And so I'm going to show you here in a minute what we did with it, what we actually built. Just kind of want to walk through that shifting from labeling every image to, hey, I just need to identify which image has a product in it and which one doesn't so that I can filter them out. And do I need to label every single image? How many do I need to do that? Well, it's hard to try that. We spent months trying to do this with Pybasa, manual tools. We tried to build labeling tools. It just didn't work. So the other piece of this is the private workforce. We've got sensitive data. We've got things in our plants. We don't necessarily want anyone and everyone. We don't want to give it out to Mechanical Turk. So having private workforce available where we can enlist college students, interns, different teams. We can have different segments for different people that are experts in products. So we can create private workforce. That was another big deal for us. And then also the UI. We found that cool, bounding boxes is good, but when you got a huge volume and I just want to filter through some stuff, we need a different type of interface. So kind of a little catch here at the bottom. We were able to build a model on 120 different classes we created a custom interface with 29 lines of HTML, and we did that in a week. So let me show you how we did that. So there's some cool stats on the side here. If you look at this is actually a screenshot from what we're using. We built a custom interface. So this is in SageMaker Ground Truth. Anyone fans of Silicon Valley, the show? Yeah. So hot dog, no hot dog? Well, we created a chicken, no chicken. And it's product, no product. Basically, show me things that have images. So this one's showing which ones they are. Tell me, using the active learning, can I filter out all of the images that don't have products so that I don't have people trying to label an image that has nothing in it that we care about? So because of our remote connectivity, we could only send one image a second back. So we just had a camera putting into S3 one image a second, and so there was a lot of noise. We had 6 million images before we knew it. Like, we're going through there is a lot of images with no product. So when we got into SageMaker Ground Truth, the first thing we did within a couple hours was create a model that basically just filtered everything out that didn't have products. So we just labeled a couple hundred images that had products, some that didn't. The active learning kicked in, and we ran that model against the 6 million. We ended up with 21,000 images. That was within a few hours. That was something we had worked on for months. It was awesome. And then, on top of there, how do we then take those next data sets and quickly through and classify those to the right products? And so you actually see this mobile on the right is actually a screenshot from my phone. I was standing in line waiting to vote for like 2 hours. And I sat there and labeled images. It's pretty cool. So the architecture behind this kind of show you the flow and what we did. Like I said, images went into S3. We load them into SageMaker Ground Truth. We start to filter through them. So you can see here's another one with our real product. We're doing bounding boxes, label that. So we had a private workforce. We had set up 6 to 8 people labeling them and just started to filter through them. So on top of that, once we created a model, we could deploy that out to AWS Greengrass. We had Lambda. And from there, we had to get it to the edge. Like I said, our edge can be complicated. So we built a Snowball Edge cluster. We have Greengrass on there and the machine learning runtime in Greengrass where we can deploy models to. Second, at the plant, now I've got inventory. So I've got these racks move around. How do I start to actually detect them in real time, what they are, and do something about it? So we put a camera up, just $1,000 security camera type deal, nothing fancy. Put it up, start streaming it back to the cluster, run the inference in real time against Lambda. Then on top of there, we can do 2 things. We can say this is what this product is with this level of confidence, but also think about that active learning piece. If I have something that can tell me there's something on the scale right now and I want an image, can I take just that image instead of blindly taking one every second? Can I just take the images when I know something's on the scale? And so we're doing inference at the edge that will let us filter out the images more efficiently now and also identify the product in real time. So really cool stuff. Not that complicated architecture, complicated to pull off in the first time, but now we're getting it down. So here's an actual application we built. I couldn't be more proud of the team. We built this application pretty quickly, but think about this. We've got a guy in the plant that now can look at this application and in real time have inference running and tell us what the product is. And so we've turned the guy that's looking at hand signs and all that kind of stuff into a labeler. So he's doing the confirmation. So we've got an image that comes across, tells us what it is. We can register it as inventory. We've also got it hooked up to the scale. Out of that now, can that guy reinforce, is this the right product? Is that the wrong product? And when he and the model don't agree, can we send that back to ground truth for additional verification using that tool? So when we first got our hand on SageMaker ground truth, that's why I was labeling in the voting line, because we wanted quick turnaround, we wanted to try it. So in 7 days from when we had our hands on the tool in our account to a model deployed at the edge running live inference was 7 days. We spent months trying to get this right before. So now, our first model was 85% accurate. Now, can we use this application? Can we use ground truth? Can we iterate that? Can we get it 95, higher percentage, so that when people are coming across it, there's no scanning, there's no hand signs, there's no nothing. They're just in there, push product through, it automatically recognizes it, and we can start tracking it. So couldn't be more proud of the team for building this out in such a quick time. And thank you for Amazon to really stepping up to bat to bring the right people to the table. So our next thing is we start showing this off, and people are like, man, can I do this? Can I do that? So we got to build a robust pipeline, a feedback loop, and how do we deploy this thing at scale? So that's what we're working on now. A lot of fun. Learned a lot from our team. It's just amazing what happens when you put a bunch of smart people in a room and don't obstruct them. Let them go, let them do the right thing. So that's all I have.
Just going back to the value proposition of ground truth. So again, re-emphasizing, so 3 main value propositions here. So one is it makes data labeling easy to do. The second one is about accuracy. So when you do the data labeling, you get highly accurate labels as part of that, which then you can use to create quality machine learning models. And the third value proposition is around the cost efficiency. So the more active learning and auto labeling kicks in, your overall cost goes down for your labeling jobs. Now I'm excited to announce that we are launching in 5 regions. So these are US East 1, US East 2, US West 2, EU West 1, and AP Northeast 1. So these are the 5 regions we are starting with, and obviously we'll keep adding more regions as we go further. Now, here are some of the customers who have been using ground truth. And my special thanks to Tyson Foods and Chad and team.
Wonderful.
Yeah. Now, with that, I think we're mostly done with the presentation, so we can take questions right here. And just a few more things to add. We have a session just after this in MGM. That's the workshop on ground truth. So we're actually going to go through the product in more details. You get to try it with few live sessions and all of that. Okay.
I think there was a question over here.
Yeah, Chad, you can join.
Yeah.
Great presentation. Is it on? Great presentation, thank you. I'm just curious, does ground truth have a mechanism for determining how many humans are going to see the same image to relabel? And does that change? Do you set it? How's that work?
So when, can you hear me? Yeah. Great. So when you create a labeling job, so first of all, you can specify how many workers you would use as part of the labeling job. So we have a default, but you can configure that. And then, like depending on the type of the workforce you use, let's say you sent it to the public workforce. So the corresponding number of workers would see those labeling tasks. And then we have Cloudwatch logs and metrics that you can monitor in your own account to see how many of these tasks are being performed by humans. And if you have turned on active learning and auto labeling, then you would also see what percentage is being auto-labeled versus being human-labeled.
But for a given image, are you setting that I want at least 5 people to look at this one image?
Yes, I think so. If your data set is comprised of, let's say, 1,000 images, so for each image, it would be sent to the corresponding number of workers, right? And now, I think Pietro explained that. Like when we get the responses back from the workers, so let's say I put 5 workers and they did the labeling. So we do the consolidation of those annotations into labels. And we use different algorithms. So IOU was, in the case of bounding boxes, But then depending on the modality or the use case, we have different algorithms to consolidate all of that. And that consolidation actually gives you higher accuracy because let's say if one label was an outlier, so that outlier would be actually removed out of the consolidated labels.
Thank you.
Yeah, go ahead. I think we'll have to move the mic around. So, yeah.
Yeah, it was a very good presentation.
Thank you.
I have a question. So we already have a labeling company that's doing stuff for us. If I have set of labels and images, can I import it somehow into auto labeling or into SageMaker labeling and see if Active Learner improves it, or like, you see what I mean? Like, can I train an auto labeling task and test it out and see if it's doing better, or?
Yes, so let me try to answer that. Like when I was showing the demo, I talked about an input manifest and an output manifest. Right? So an input manifest is, like we call it an augmented manifest. So think of it as, it's like in JSON lines format. So it's a series of JSON lines, like human readable. So what you can do is, like if you have already done labeling with some other vendor and you want to bring it in, so you have two options. So once, like you just prepare your data to be in the input manifest format that we expect, right? Or if you have images that have like sort of pre-labeled, you can do crawling as part of the console, and you can just use crawling to create a manifest that would be consumed by the labeling job. So different ways to do so. And I also mentioned about like when you have the manifest, you can also do sampling querying on it. So if you have different types of labels, let's say they are multi-class, and you want to only label certain classes out of that, so you can do querying and filtering and sampling also as part of the console experience.
Yeah. I think there's some questions back here.
Yeah, also thanks for a great presentation. I was wondering for the text classification tasks, if I have a large corpus of multilingual data and I want to put it out to, say, Mturk or something, does it support the ability of being able to route data that we, say, know the language of to like people Turkers who know those languages? And the follow-up question, how difficult do you think it is to extend the custom labeler to something like speech or audio data?
Yes, so two questions here, and Peter, feel free to jump in.
Yeah, I don't know the answer. I think Jessica may know the
but-
answer to
but
the first question.
Yeah, I'll take it.
Yeah.
Like, just, so for the first part, like, so when, let's say you have multilingual and you have text classification jobs, right? So like when you send it to the public workers, so there is this notion of quals that you can create. So you say if it's French, then it should just go to workers in France. If it's, like say, my native language like Hindi, then it should just go to India, right? So you can create quals like that for the public workers. Right? And we'll continue to add more functionality around that. Now, to your second question around
Custom interface. Custom interface.
Custom interfaces, yes, sorry. Yeah. On the custom interfaces, yes, like there is enough functionality there. In fact, we have a set of templates that are already there as part of the custom tasks. So speech processing is a custom template that we already have. So you can use some of these pre-built or templates that we have as part of the custom tasks to do what you want to. But let's say that doesn't meet your need. The UX for the custom task could be very much defined by you. And then you get these lambdas like the pre and the post lambdas, where you can hook in any business logic, any application logic that you want to do prior to annotation and post annotation. Say for consolidation, you could do that. So a lot of flexibility as part of that.
There's a question over here.
Yeah, go ahead. Can you just use the mic so it gets recorded as well?
At what point
Thank you.
We'll get to you, Balaji.
Do you have any tools to do calendar-based labeling or geographical or weather-related labeling, for example, historical weather? The data we have are not images, but they basically have a date attached to it in their location. So, but to enhance that, we would need to know what was going on that day, what day of the week was it, and was it a holiday, or what weather was at that point? Do you have any tools to do labeling based on that? I mean, we can probably build something, since you have a custom, we can attach lambdas and do something that way, but if you already have something like
Right now, you would have to do that with custom tasks, but that's a kind of a good feature request, like we could take a look at that. But presently, the custom task is the answer there. We have just a couple of minutes.
I understood you supported pre-labeled data. We already have a large set of that. Do you also support confidence factoring on the labelers of pre-labeled data?
Yes. So when we output the labels, they also have a confidence score attached to that. Yeah. So as I said, like when you either bring in some pre-labeled data or you take output of our labeling job and you create yet another labeling job. So we have, as part of the sampling, filtering and querying, you can actually say, I only want to now label images that have a confidence score less than, say, X or Y. You could do that. So there is a querying facility as part of the manifest sampling and filtering.
That wasn't quite my question. I have a large pre-labeled data set, and some of the labels I know some of the labelers are higher quality than others. When I input my pre-labeled data set, can I specify confidence around particular labelers as I load it? So it's already built.
Yeah, right now that's not available as part of the APIs and the console.
Short. At what point do you actually decide that you don't need Mturks anymore and this model is sufficiently well trained? At what confidence level do you say, I don't need Mturks anymore, I don't need human intervention anymore?
I can answer. So the answer has two parts. One has to do with the science and one has to do with the interface with you, with the customer, right? So on the science side, we estimate online at any time what is the confidence of so we have a value of confidence of the algorithm that gives us a probability that it's going to be good enough. So we would like to receive, and now I'm talking like a scientist, we would like to receive from the customer in some form their requirement on the tolerance or error rates that they're going to be willing to put up with. And then I'll work on that. And as soon as my algorithm is hitting that probability level, now the fact is, this is a image by image evaluation. So it's possible that I may be annotating automatically 150 images and suddenly one comes that, oh my God, it's so different from anything else. Send it to the annotators dynamically. Now the second part of the question is, what should we expose to you, the customers? Should we give you all of the knobs and to tune everything? And so the choice at the moment is to make it very easy for people to use, and therefore not everything is exposed, and we're listening to you to hear what do you want to be able to control. And so in the next few months, we'll rethink our strategy. But at the moment, it's very simple, and that's the idea.
Thank you.
Yeah, that's time.
So thanks a lot. I think we're almost to the clock now, over the hour. And yeah, so thanks.
Thank you.